So, und wir haben jetzt ein bisschen Zeit, aber ich würde deswegen die Gelegenheit nutzen, schon mal vorab auch auf morgen hinzuweisen. Morgen gibt es hier auch nochmal Programm. Wir haben morgen, fangen mit dem Thema Nachhaltigkeit an. Sustainability, Nachhaltigkeit ist ja auch eines der großen Themen hier auf der Messe, neben Digitalisierung und KI und MRK oder Robotik generell. Und da gibt es eine Keynote zum Thema Nachhaltigkeit, wie KI für die Nachhaltigkeit, wie KI Nachhaltigkeit unterstützt in der Produktion. Und anschließend haben wir dann nochmal eine Podiumsdiskussion zum Thema nachhaltige Produktion und wie sich die umsetzen lässt und wie auch da Lösungen dazu beitragen können. Also morgen auch nochmal spannendes Programm und neben der Nachhaltigkeit haben wir auch dann wieder die anderen Themen, die auch jetzt uns schon die ganze Zeit im Forum umtreiben, sprich KI, Robotik und Digitalisierung. Also morgen geht es ab 10 Uhr hier auch nochmal weiter, oder beziehungsweise genau das Forum geht morgen auch weiter und hier geht es auch weiter. So, und zwar mit Siemens, Matthias Loskyll von Siemens. Und er wird über the autonomous factory designed by and for people sprechen. Discover the role of AI and their suitability for industrial use. Also KI, auch hier wieder wichtiges Thema und ich freue mich auf Ihren Vortrag. Bitte schön.
Vielen Dank. Thanks a lot, dear ladies and gentlemen. The autonomous factory designed by and for people. This will be a bit of a visionary talk, but we will also have a look at concrete examples, concrete use cases where we work with our customers to get AI into production. First of all, what is the autonomous factory? This is our vision of the production of the future, of a smart and self-organizing production. It will be highly flexible, resilient, and sustainable. This is a bit abstract, so I invite you to have a look with me into the future and watch a short video. This is Zoe, a little girl who builds a toy robot just based on her imagination. Wouldn't it be great if she could order this little toy robot as a really produced toy with just a fingertip? Before production of this little toy robot can start, the whole supply chain must interact with the autonomous factory. The material must be delivered to produce the robot, and now we are in the material receiving area. There you can see how autonomous forklifts are able to unload load carriers and raw materials from a truck. For this, different AI technologies will be needed, like object detection, pose estimation, and the generation of the overall workflows of these forklifts. These autonomous systems will be equipped with advanced safety functionalities to allow for safe human-machine interaction. And while our little girl Zoe is waiting for her robot to be produced, in the factory, different intelligence systems group together to solve tasks collaboratively. And to do so, they have to exchange information, for example, perception of their environment, and synchronize their world models. But not every task can be handled with just a few machines, but sometimes we have to break down very complex tasks into subtasks, like the assembly of the robot, for example. And to do so, we will need a central intelligence still, which is able to optimize the overall production process together with inter-plant logistics processes and assign machines with the adequate skills accordingly. But even the most intelligent systems using AI could reach certain limits. For example, if they are not confident about a certain prediction, they will ask for help. So this is a feedback loop between human and machine to really give feedback to the system and let it learn continuously. So that's just a snippet of our vision of the autonomous factory of the future. But I think it gives you some idea how this could look like. So maybe it's 10 years, 15 years away, 20 years away, nobody knows. But we really believe that this is key to hopefully make every wish come true, not only of this little girl, but also of every one of us. What's really important for me, and I think you saw that in the video, the autonomous factory is designed by and for people. So this means we are not talking about lights-out factories or something like that. There is the human operator and supervisor in a central role. So this means there will be interaction between intelligent systems and the human being. There will be tasks that only can be taken over by humans, because the human is, in the end, unbeatable in terms of creativity, in terms of problem-solving skills, in particular in situations that you haven't experienced before. So it's all about the interplay between artificial intelligence on the one hand side, where you have intelligent algorithmics, you have super fast processing power, can process huge amounts of data. On the other hand side, you have human intelligence, creativity, as I said, problem-solving skills. Bringing these things together, really getting the interplay done, this will be the next level of automation that we can achieve. Now I talked about the role of AI, and this is really one of the most crucial technologies in this game and in this vision of an autonomous factory. And in the meantime, you can see AI all around the place. It's extremely versatile. You can see it in different use cases in different industries. For example, of course, there are use cases that are a bit more simple, like anomaly detection, predictive maintenance. On the other hand side, you have even the more complex use cases like process optimization, autonomous systems, as we saw it in a video, and you see it around here on the fair as well. More and more intelligent robots, for example, are coming up. And you can see that in every vertical, in every industrial branch in the meantime, in automotive, electronics manufacturing, batteries, you can imagine. And I brought 3 concrete examples. These are real customer cases that we've worked on at Siemens to make it a bit more concrete, a bit more explicit. The first use case is about handling of objects, grasping of objects. This is an important topic in material handling in production, manufacturing, of course, but even more complex it is in the e-commerce business, in distribution centers, for example. So just think about your favorite online store, where you have a shopping basket with different items. They probably look completely different. But somehow, the distribution centers and logistics centers out there must pack these together into your postal package, so to say. So these bin picking and piece picking tasks, these are usually performed manual today in e-commerce because you have so many different objects around that you cannot even program beforehand, obviously. So these are arbitrary, unknown objects, in particular in this area of application. And in distribution centers, for example, you have around 500 to 1,000 picking operations per hour, which are performed manually today in most of the cases. So that's the use case, and there we worked with several customers already. And what did we do? We developed a neural network, so a deep learning model, that is able to calculate the optimal grasping point for every arbitrary object, even unseen objects at runtime. So this means you can throw any object that you want with a camera attached to the robot arm, with the AI model calculating behind. The robot will be able to grasp this object and to handle it and put it into a box, for example. And this is something you can actually experience on our Siemens booth. I will show you later on where you can find it. There is a demonstrator. There are colleagues around that can explain it to you. You can even bring your own object and own item. As long as it's not too big, you can just put it there, and the machine will be able to handle it and grasp it. AI also finds its way into the automotive industry. Did you know that in the car body manufacturing, where different metal sheets must be joined, you need around 5,000 weld spots to join these metal sheets? 5,000? That's a big number, right? So how could you ever inspect these weld spots if there are defects, if there are weld splashes that might be sharp, for example, that must be removed because they are safety critical? How is this done today? sample inspection. So you just have a tiny portion of these weld spots that are actually inspected. So that's quite a big risk. It's high costs because you might have a lot of rework being done. So that's a challenge, and we tackled this challenge together with a big automotive customer in Germany. And with the trained machine learning model that analyzes the overall process data of this welding process, we were able to increase the defect detection rate by 17%. So significant value already. And even more, we have a 100% test coverage. So this means no sample inspection anymore. But for every single of these 5,000 weld spots, we can calculate a quality score. And we exactly know if this is a good one or if there might be a problem. Last use case. And this is related to renewable energies, to sustainability. Because if you have a look at these silver bars behind me, these are so-called monocrystalline silicon ingots. So these are huge bars of silicon, which are pulled out of a big melting pot of liquid silicon, so like 600 liters, for example, melted, and you pull out these ingots and the silicon crystallizes, and then you have these huge bars. And these are cut into wafers used for production of solar panels. Or for semiconductor industries, it's a very similar process and technology, actually. So a customer in China who produces these silicon ingots reached out to us and said, I have some quality problems. I have some problems with my process. Could you please have a look and help me to improve that? And we tried it. We tried it out in a lab environment first of the customer. And the results were so convincing that we rolled it out to the factories in northern China. It's running at more than 30 machines already now. And I will tell you why this is so important. This is a super complex process. Today, everything is programmed manually, and you have people running around having a look at the process, how the chemical behaves, so to say, if you need to adapt some parameters. So it's a mixture between different programming, late feedback, if your parameter changes really have an effect, and a lot of human effort still. So we trained an AI model based on historic data to improve this production process. And what did we achieve? I said we rolled it out because it was so significant, and you can see the numbers here. We were able to improve the production speed by 8%. This is already significant improvement because throughput means you can produce faster, you can produce more, obviously. But even more significant and more outstanding are the quality KPIs and the numbers that we achieved there. We achieved a quality improvement by 65% or even 78%, depending on which quality KPI you take into account. When we talk about quality, it's all about a flat surface. You don't want to have structure losses, for example, because in the end you want to have high quality wafers that you use for the solar panel production. So really outstanding achievement using AI, and this is a really complex use case. We are not talking about anomaly detection or predictive maintenance. These use cases are also relevant, and we have to tackle those. But we are talking about a much more complex use case where we really go into the control of a process, where we really optimize the overall system. And in my opinion, there is so much potential still out there. If we are going to tackle these use cases, we can really, really significantly improve production processes even more. So these were some success stories, but we are still at the beginning of this awesome journey. So you see behind me this infinity loop, right? Maybe some of you know it from DevOps. It looks a bit different. It looks a bit similar, sorry. It's machine learning operations, we call that. So you have this one loop where you build your AI model. You have this other loop where you run, where you operate your AI model really in production. If we have a look at the different phases, how AI models are built and then run, in every phase you will find challenges still today in industrial production. Because AI in industry is so much different from AI in the consumer world. For example, starting in the beginning, when you want to plan and specify your requirements, it's really important to have such KPIs defined. how are you going to measure success of your AI model? What's actually the benchmark? So maybe there is a running system today. How do you really make it measurable that your AI really works? Really important point. Then it's, of course, about data quality. We often face imbalanced data in production. And this will lead probably to low-quality AI models. If you have low-quality data, probably your AI model will be low quality. So it's all about data connectivity. It's about using synthetic data generation, so using data from simulation, for example, from the virtual world, to augment your real-world data and improve, therefore, the training of your AI models. Then it's about validation of your AI model, even certification in the future. There are authorities discussing about that. Maybe you heard about the EU Act, which is currently under discussion. So for safety-critical applications, for example, or whenever data about us as humans is involved in the training processes of AI models, there will be certifications needed and auditing needed of AI models. This is also something we will have to take care of in the future. And then you're going to deploy your AI model into the real world. It's running, and most projects actually stop here. So you think, okay, now POC is running, now let's go. But it's not like that. AI will not run forever and just work, but usually performance of AI models go down over time. Why is that? Because the data changes. Some sensor values might change, maybe some people in production change something and tune around on the hardware. This might have effects on your data. And this might mean that your model never saw this data before. Could call this data shift or concept shifts, for example. So this means the AI model will not be able to deal with that data. It will not be really accurate anymore or not confident enough anymore to really make a decision. And then you have to take care of that. And you better want to know that this is happening. And this is what we call AI monitoring. So you have something like a watchdog over your AI model. It controls your model and then understands if something is going wrong. And then you can retrain and improve your AI model. So you see a lot of challenges still going on. Good news is, we are working on that. We're working on all these challenges and all these phases. We will make AI industrial grade, robust, reliable, and trustworthy. That's a goal. And this is still quite some journey. So remember again the vision video that we saw at the beginning. I said 10, 15, 20 years, nobody knows. It's like a North Star for us that we want to build on. It's an evolutionary journey that we have to go step by step. And now's the time to start digital transformation in every industries. And really go step by step towards this North Star of an autonomous factory. Flexible production, individualized production, this must be the goal. And improve your production processes further and further. But we cannot do that alone, nobody can do it alone. We have to work in ecosystems. That's a word stressed a lot, I know. But I really believe in the space of industrial AI in particular, this is crucial. So companies have to work together to really solve this big elephant of different challenges that we still have and really move step by step into this bright future. In this sense, I invite you to have a look at our Siemens booth. You can find it in Hall B6, booth 302. Can visit my colleagues there. They can tell you more about our different offerings, in particular about the Siemens robotics AI solution, the flexible grasping that I showed as one use case. Have a look at the demonstrator, discuss with our experts there, and have fun. And if you want to connect, these are my contact information. Feel free to reach out via LinkedIn. Also happy to send you a link to the full version of our vision video. This was just a snippet. We have a 5-minute version where you can see the full vision. And thanks a lot for your attention, and looking forward to your questions.
Super.